This conference will now be recorded.
Yeah, so this is 14. So I'm from Microsoft. I will talk a little bit about the echo mirror enhancement. So in SONiC, echo mirror feature has been there for quite a while. In Microsoft, we have a specific tool called Everflow. So that tool heavily use this feature. So for this feature, we create a mirror session and we attach some specific echoes to the mirror session so that we can duplicate particular packets with some specific patterns and mirror or manipulate them remotely. So that's a brief idea of what's the echo mirror feature. And so the enhancement will not going to be a lot. It's just adding some new matching fields so that we can make this tool more powerful, especially on the IPv6. So let's first take a look at the current mirror echo table field list. So right now we have the mirror echo table supports all this kind of field. It supports Ether type, the IP protocol, source IP, destination IP, and the port, and the TCP flags, and the echo, and the source port range, and the destination port range, and the DSCP value. So that notice that we're supporting matching all kinds of IPv4 packets and the non-IP Ethernet packets. So I've listed two use cases here that we currently need for this mirror echo table. So the first one is to mirror the R packets using the Ether type 0806 so that we can mirror the R packet to the remote destination. This feature is used for the fast reboot. So if you take a look at the fast reboot feature, it will probably mention a little bit about this. The other use case is for mirroring all this kind of patterns, which is used for Everflow, so that we can match and mirror specific packet patterns to track potential like packet loss, something like this. Packet got lost and nobody noticed that. So if we have the mirror feature, we can try to track these kind of things. So the new enhancement introduced such kind of things. It introduced these new psi attributes into the SONiC. So, actually, I noticed that the screen didn't change. Sorry, let me get a little bit.
Can we see this previous slide?
Yeah, I noticed that the the slide is not. Give me 1 second. Yeah, I didn't know that. Uh, yeah, okay. Okay, nice. Okay, so yeah, that's something that I want to show. So, yeah, this is a list of the previous, the current echo table view list. So that's all the attributes we currently support. And this is a new echo table view list that we want to add. So on the right side, we notice that 3 of them are IPv6 related. So this means that within this, with this enhancement, we're going to try to support the IPv6 for the mirror echo table so that we can mirror IPv6 packets. Also, we want to introduce imports field so that we can mirror some packets from specific interfaces. We also specifically add this IPv6, ICMPv6 type so that we can mirror some specific neighbor discovery protocol packets. So I will talk a little bit about the use cases here. So the first use case is a mirror neighbor discovery protocol (NDP) packets using the ICMP v6 type set as like 133, 134, 135, and 136, 137, so that besides of like mirroring R packets, we can also mirroring the IPv6 NDP packets. This is also used for the fast reboot. The other three use cases are for the are the requirements from the Everflow, so that we can, for example, mirror all the traffic that goes into some specific interfaces, or we want to mirror all the IPv6 traffic from on a device, or if we want to mirror some specific IPv6 source destination combinations, that's also the use case. So one notice is that we want the source and destination IPv6 to be 128 bits match, so it's exact match. And for the imports, that's according to the size spec. We want it to match the front panel interfaces. So no matter if the interface is like part of port channel or part of the VLAN or something. So this imports is only only going to be front panel interfaces. So that if the packet goes into this front panel ports, it will be a match.
Can you specify and explain to the people that are attending this whether this is it statistical mirroring or is it full mirroring?
Sorry, can you be louder a little bit? Is it what's the question?
Is it statistical mirroring or full mirroring? Are you statistically mirroring for a specific source, destination, and port packets, or is it 100% of the packets?
100% of the packets. So it depends, right? It depends. For example, if I just mirror the import, I just have the imports as a match criteria. I would just match all the imports, all the packets incoming to these imports, right? Does this answer your question?
Yeah. I was just asking for the benefit of others.
Oh, okay. Yeah, thank you. So, according to the as for the implementation, so I think from my rudimentary knowledge about the chips, I've heard that some chips will support like combining both IPv4 and IPv6 in one table. That would be great, so that we can just extend the current table to support IPv6 and to support some extra like fields, such as the previous like the imports and the ICMP type fields. But for some other chips, they might not be able to combine both IPv4 key and IPv6 key. So this means that we might going to like create two tables according to the chip capability. So that for example, the one table, that's the current table, that would be used for the IPv4 and non-IP packets. That's the same as the current table. And we want to create an extra table that's for IPv6 only, so that we can support all the IPv6 functionalities. So in the future, I think once we have some, for example, feedback loops, we can first try to create a full table and then check for the return value and see if it fails or if it succeeds. If it fails, then we can create two tables afterward and see what's the result. But the stage 2 will require some many changes on the current architecture. It requires the feedback loop, so that might not happen very soon. So I think for the current enhancement, we're going to work with the stage 1. We're going to have some hard-coded things in the SONiC so that we can, based on different chips, we can create either one table or two tables so that we can fully support everything.
Can I ask a question here?
Yeah,
Sorry.
sure.
If you can create two tables, why would create one table fail?
Uh, create one table won't. So create one table, but the table contains more fields. It might fail. So it means that the key will be longer. So that, for example, some chips cannot like have both IPv4 and IPv6 match on the same table. So that
I
might be the reason for the failure. Yeah.
Okay. Sounds like you prefer one single table. Why?
Yes, because one single table will definitely save some like space in the chip, and it's easier for maintenance.
I see.
Yeah.
Okay, thanks.
But so because we might have two tables, so I will going to have a design documentations on that, and because it's not a big change on the current mirror feature, so I would just add some extra words on that to cover the enhancement. And the test, so all the IPv4 tests are there and they are running smoothly. So I would just add some portion of the IPv6 tests and as well as the imports so that it will fully cover every new features. Other than that, I think we would like to see if there will be command line tools that can be used for creating and removing echoes other than the mirror sessions. Right now, we are able to create and remove the mirror sessions using the command CLI, but we also want to use the command line to have the echo modifications because the echo loader and the JSON file might not be that user friendly when a user is on the device. So that's basically everything that's in this enhancement. So any other questions?
So if I specify a destination,
Yep.
and let's say the destination is on a server-facing port,
Yep.
and there is traffic that is being received from multiple ports, and let's say that the port is actually oversubscribed, and I actually want to capture anything that's coming in for that destination clearly from the northbound facing ports, right?
Yes.
So how will I end up mirroring? And for
I
simplicity reason, let's say that 10
mhm.
gig port south and four 10 gig ports are sending traffic. So how would the mirroring work in this case, and how will
so
those
so
packets go out?
so you already know the destination IPv6 address or not?
Yeah, I do. So the
So
destination is towards the server.
yeah, so if you know the destination IP, then I think I would just use the destination IPv6, the destination address as a criteria to match the to
No,
match. Mhm.
my point was not so much how I match it, but rather what happens to the traffic. Because if I have the links are running, let's say at 90% capacity,
Yeah. Oh, so you're
clearly,
saying that it might cause traffic congestion or
yes. And I want to
I
see what are the flows for that destination that are causing this. So I match the destination because I don't know the incoming flows. How would the mirroring work in this case?
if the traffic of the mirror is very large, and for example, if you're having like like mm, if the bandwidth exceeds uh, the outgoing interface, it might cause some drops. So I think in the future we're going to introduce a policer on this mirror session so that we can rate limiting the mirror sessions traffic. But right now I think we don't have such kind of like protection at
Okay,
this moment. Yeah,
thank you.
it might be the next stage enhancement. So we're going to introduce a policer mirror session. I think I've already created the pull request in the side so that it yeah.
Hey, could you basically, catch this thing in the configuration? Say that, okay, the mirrored port to which you are basically going to mirror to has the same or higher speed than the one that you're, catching the traffic from?
Use a configuration to limit this kind of actions you're saying?
Exactly.
That
I think
is that. Mhm.
I think the problem really not about the link bandwidth. It's about the traffic volume. When we deal with congestion, for example, if let's say the destination maybe only have 1G and then the source link has 10G, but if the traffic on the 10G port only has 100 meg, then mirroring is still okay. It's really about traffic volume. So not sure that we need to do the configuration check to limit which port we're going to mirror to.
Yeah, as long as the port, the total mirror bandwidth fits in the outgoing port is fine, right?
Yeah, but you can it's not easy to like to track like what's the current what's the current time of the volume of the traffic. You only know the speed of the link, but you don't know the speed of the traffic, a specific.
Yes. And I mentioned that because we have an actual specific case, and we actually see it in deployment where the customer is actually interested in saying, okay, I know that my link is oversubscribed, but I'm actually interested to understand, given the destination, what are actual the flows that are coming in that are oversubscribing that link.
Yeah,
Hence,
I think.
could use the mirroring, right?
Yeah. So according to the size spec, one approach is the policer to attach the mirror session. The other one is to sample the mirror traffic. Yeah.
And I think there is one already another mechanism is to, I believe in the mirroring session we have a queue attribute to specify which queue those mirror packets go out. The TC. So in this case, if and then we can configure on the destination port. I have like priority schedulers. In this case, we can put the mirroring traffic as low priority, so it won't affect the data traffic. I think that may have been already implemented, the TC options.
So I remember there was some discussion about saving resource occupied by these echo tables. So we want to do some more echo rule level port binding. Is there any progress in that direction or?
Saving the size of the echo table about for on the bind list of the ports for the table.
Right. So I remember there was some resource issue. Since we have to create an echo table for any rule, then it's occupying too much TCAM resources.
Because it's matching all the it's applying to all the interfaces. Is that the reason?
Honestly, I am not so familiar with this area, but I just remember we want to make some optimization in how to utilize the TCAM resource in SONiC. I'm not sure if that you have done some work or still a blank area.
I think it's not a blank area, but it really depends on different chips and different it depends on different chips. So I think we can like discuss offline about like which chip it's using and how it's a little bit about the side implementation on how to achieve that. But for the feature wise, this that's a list of the fields that we want to use.
Okay.
Mhm.
Will these new rules are only applicable to the mirror SL table? I mean, like we have other SL table to deny or to forward some packets. Can we also use these new rules to those tables?
Yeah, that's a good question. For the source IPv6 and destination IPv6, they've already supported. For the import and the ICMP type, I think once they are supported for the mirror echo table, they will also be available for the other regular tables. Yes.
Okay, thank you.
Mhm.
Okay, any other questions or comments? Sortian, you might need to upload this to the pull request
Sure.
in the SONiC GitHub so that people can give comments there.
Sure.
Okay. Okay, if there is no more comments, we will go to the next topic.
Okay, thank you.
Yeah. Thank you, Sortian. Yeah. The next one will be Sud Hassan from Dell, leading the conversation on dynamic transceiver tuning.
Okay. Hi,
Can you
Zen.
try
Thank
to
you.
share your screen? Yeah.
I'm having a problem in sharing my screen. So the icon is, I'm sharing from the web. I'm unable to share because
You're
I think
unable.
I'm.
Let me try. Let me try to make you presenter.
Yeah,
Okay.
yeah. Okay. I think I can share it now. So
Okay.
thank you.
Great. Yeah, we are able to see it. Yeah.
Okay. Thanks. So hello everyone. This is Sudarshan from Dell. So the document which I'm going to present is about the transceiver tuning in SONiC. So what is the necessity for this is, as we know, in the deployment, there are different types of cables and optics that will be interconnecting switches as well as servers and other devices. So having a wide variety of optics and DAC cables, there is a necessity for tuning the specific ASIC port settings for each and every cable. Say if there is a 2-meter cable or 5-meter cable, or there is a DAC 1-meter cable, or you are using SFP optics, each might require specific settings to work properly. If such settings are not done, the port might the traffic going through the port might face some issues like CRC errors might prop out, or sometimes even the link may not come out. So some example of such settings as pre-emphasis settings, but these are not restricted to only a little. There might be even specific ASIC related settings that might tune the amplitude and other SerDes settings. So in order to, so currently we don't have a support for programming such settings either through SOI or in SONiC. So to solve this, we have defined a certain SOI attributes which we raised a pull request and presented in the SOI forum. So this is the pull request. So for currently we have raised for 3 attributes. So the first attributes is the pre-emphasis, which is U32 list. So the list is because a port might be having multiple lanes, and each lane needs to be programmed with a specific value for the server settings. So first we define this pre-emphasis. The second attribute is the iDriver, and the third one is the pre-driver. These are amplitude controls. So we defined these 3 attributes, and we presented it in the SAI meeting a couple of weeks back. And so if any vendor does not support it, they can ASIC vendor, like they can return not supported. And if there are any more settings that needs to be defined, that can be defined following this in the list of port attributes. So in SONiC, how we try to solve the problem is for each and every SKU, we define a specific file. So this will be under a device platform only string hardware SKU, and the file will be the media settings.json. So I'll give a sample of the file. So this is how a sample file looks. Though the file will contain settings for each and every port. At the first level, it will be the which port the specific settings are present, and under the port, the second level of will be the vendor. So whenever media is detected, say DAC cable or optics, we will the vendor is identified. So wait a minute, yeah. So I will.
Hey, Suda-san, quick question. What can the port be expressed as a range?
Sorry?
Can the port number be expressed as a range, or did you have to do every single one individually?
We have to do every single one individually. So I have given one port. So if you have say 20 ports, you have to give all the 20 ports settings and all the optics that are supported and the settings.
But isn't that going to make the file irritatingly long? Since most ports are going to be the same, aren't they, in a typical system?
It may not be like the pre-emphasis settings may vary from port to port. So
well, they may do, but what if they don't?
If they don't, I think we can have a global. That's a good question, actually. If there is no variation, we can have a global setting above all the ports, so that if there is no port specific setting for the particular media, and if it's present in the global setting, meaning that all the ports have the same setting, then the specific setting from the global field can be chosen. I am not thinking that here.
What I'm suggesting is you express it as a range. So maybe port 1 to 32 might be the same, right? And then you might have other ports that may be different. I think that's the most flexible way of doing it.
Okay.
Yeah, I agree. I think what happens is that what if half of the ports are one, and then half of the other half of are different? Then the global doesn't really work here.
Okay. I got it. Yes.
Okay, so I think we initially thought that since today we have either 32 or 64 ports, so it's like it may be better to generate the entire list for clarity. But I think if you believe that it's going to be useful, I think we can do this range thing.
Yes, we will work on that.
Okay.
So yeah. So
Clarification question. So for this port, are you thinking about the breakout port or this non-breakout port? You know, when you're specifying this file, is this representing a single physical port, or you actually, for example, a 40 gig breakout to 10 gig, do you specify those 10 gig ports in this file, or you only specify the 40 gig port in this file?
It will be like it's in non-breakout mode, but since there are 4 lanes, the settings will be like lane specific. I will visit when I am describing the file.
Okay.
So whenever a media like optics or DAC is detected, so the first thing that transceiver daemon figures out is the media type key. There are 2 keys that will be constructed. So the media type key is nothing but it will be comprised of the compliance code as well as the length string. For example, if it is going to be a 40 gig CR4, base CR4 is the compliance, and the length is 3, and the key will be like 40G base CR4 3 meter. And if the length doesn't apply for the specific compliance, it will be simply the compliance code 40G base CR4. So the next key that will be constructed is the vendor key. So the vendor key will be comprised of the vendor name as well as the part number. So here is an example. Say if the vendor name is Dell, the media vendor name, and the compliance is the part number is 001122. The key will be like Dell 001122. So if there are if the multiple part numbers under the same vendor have the same setting, the key can be just comprised of vendor name. Say if there are 2 part numbers under Dell and both have the same settings, the part number can be just omitted and it can be just Dell in the file. So if you consider here, I am going a specific setting. Say under the Ethernet, I will come revisit what's default here. So under Ethernet 20, if a 40 gig SR4 optics is detected, so for 40 gig SR4, there will be a specific uh, here you can see it's listed here, and next this will be the media key. So the vendor key will be based on as I said, will be based on the vendor name plus the part number. So under the vendor name plus part number, there is a field where we have the required settings. So these settings will be read by the transfer daemon, and it will be communicated to the port or port orchestration agent. So I will come for it later. So for example, if on after detecting the vendor name, if a specific vendor type is not present, say 40 SR4, so the default values listed for the specific optic type will be chosen. So here is the example here. The first setting is for default. The second is for a say Dell 001122. If the vendor string computer is not this, then the default settings will be chosen. So one might ask, oh, what is the necessary for the default key at the media key level? Say a specific optic is detected and media key is constructed, and the constructor key itself does not exist under the port. For example, say 40 gig CR4 7 meter, the DAC CR4 7 meter, and that's not present. So some set during that time, what will be done is apart from all the listed media keys, there will be a default option that needs to be programmed for undefined optics. So that will be chosen and communicated. So this is the flow, actual flow. So whenever the optics is detected, the transceiver daemon will read the media settings from the media settings file, and this will happen only if the media settings file is present. If there is no media settings file present, say where a vendor does not require any settings, then there will be no mechanism of communicating. But if the settings is present, those settings will be read based on the port on which the media is detected, and the media type key and the vendor key, and these values will be taken and communicated to the port orchestration agent. So the port orchestration agent will convert the port to SAI port, the alias to SAI port, and the corresponding attributes for each key. Say here we have defined the three attributes for the example. One is the pre-emphasis, second is the high driver, and the third is the high pre-driver. So these for all these three, the three SAI attributes which you have listed here have been defined. So these values will be converted, and then the SAI API will, this information attribute set will be done to the SYNCD, and the SYNCD will program the corresponding the SAI that will program the hardware. So this will be the flow.
Hello.
Sudarshan,
Hello?
your voice is breaking.
Yeah. Can you please repeat? Hello. The audio is pretty bad.
Yeah, I'm trying to reach out to him.
Thank you.
Hello.
Yeah,
Yes.
Sudarshan.
We can hear you.
Yeah, I can hear you. So yeah, are there any questions?
Yeah, actually, your audio was breaking out. Can you please
Okay.
repeat from the flow? Not here,
Okay.
the other flow.
Okay.
Yeah.
Yeah. Okay. Fine. So this is the flow, event flow. So whenever the optics optics is detected by the transceiver event, so transceiver daemon. So the media settings file will be checked. If there is any settings file, then the two keys, the media key and the vendor key, and based on the optics on which the port is detected, the settings will be read, and those settings will be communicated to the port orchestration agent. And when the orchestration receives these information from the transceiver daemon, it does some conversion. One is the port to the SAI object port object ID. The next is it will map the settings to specific SAI attributes. So in this case, we have three example. We have three settings here. So and the corresponding three attributes are defined in the SAI. So this will be mapped, and once this is done, this information will be passed on to the SYNCD. So SYNCD will invoke the SAI API that will program the hardware. So this will happen. So this communication from the transceiver daemon to the port arc will happen in two scenarios. The first scenario is during the initial transceiver daemon boot up, where it will detect the each and every it will check each and every port for the presence of optics, and it will convey the information. The second is during the dynamic optics change event, where if an optics is removed and the new optics is inserted, again the transfer daemon will convey the settings based on the new inserted optics type. And this flowchart, the second flowchart describes how the media key as well as the vendor key is constructed. So as I described earlier, the media key will be based on compliance and length, and if it is found in the port, next will be the vendor key, which will be based on vendor name plus vendor part number, and again if it's found, it will the key value pass present under the media and vendor keys will be fetched and notified. If not found, each and every false case will be going back to the default values. So there will be a default value defined under say each port for media as well as for each media under a default vendor. So those will be conveyed. So any questions?
One comment here.
Yeah.
Yeah. Can you go back to the flow, the first graph, the first one?
Yeah.
Okay. Actually, transceiver daemon is started very late during the boot up phase. Is you are waiting for all the interfaces configured, and then it started to start up. So I think maybe during the startup phase, it's not able to give indication to the port to trigger the pre-emphasis.
Okay.
Okay, I think what you're saying is that for the boot up case alone, we need to have a separate, one-time service, system D service or something like that to program the pre-emphasis, and later on, transceiver daemon will take over.
Yeah, and also another comment is that will transceiver daemon pass the media setting file and send all the contents to the port OC agent?
No, it sends only the specific contents because as we know, right, the port sort is already communicating with multiple tasks, and I think the transceiver daemon is the only job of this task is to read the media, and apart from it can read the file and communicate. So that will reduce the overload on port search. So it's logically better to have it in the transceiver daemon.
Okay, what kind of media setting are needed for this specific case? Yeah.
Yes, it depends on the requirements of a particular ASIC. Say this is example we taken from Broadcom. So we require for supporting different optics as well as jack cables. We require the pre-emphasis settings and the high driver as well as high pre-driver. These are the amplitude controls. Only on programming this, the particular optics will or the DAC cable will function properly. So if there are other vendors, and I think the pre-emphasis might be common across different vendors, and the other specific settings, I'm not sure what other ASICs have in common. So if there are any other such settings, I think we can define psi attributes for them and then have the similar mapping which we have defined here.
So if my understanding is correct, is that when transceiver daemon detect a new SFP plugin, let's say, then transceiver daemon need to read this file, right? And then
Yes.
send some information to the post awk
Yes.
agent, right?
Yes.
Yeah. I'm thinking that since transceiver daemon is reside in the Pimon container, and post awk agent is reside in the SWSS container, right?
Yes.
So maybe transceiver daemon when detect a SFP plugin, maybe transceiver daemon can send out a message to the POC agent, just notify that there is a new SFP plugged, and then post awk agent to read the media settings. I mean,
Yes, yeah, that's what I was. Yeah, let me explain. That's what I was saying. I thought the same, but since the port orchestration agent, right? It has multiple interfaces and talks to multiple things. So reading a file might take some amount of work or some amount of time. So if this work is done by port search, there might be some multiple tasks which will be blocked during this. So instead, if you consider the transceiver daemon, right, the only job of the transceiver daemon is detect and notify. So instead, if we have this functionality in the transceiver daemon itself, that will save a lot of work done in the port search, or at least it will reduce the overload, because we are currently not using transceiver daemon for any other purpose.
Actually, transceiver daemon is reading the SFP EEPROM periodically and post those information to the StatDB.
Yes, yeah, that's the only task.
Yeah.
So apart from it, it can also do this reading the media settings file and notify. And if we consider what kind of this event, right, this is going to happen only during the media detects or during transceiver daemon, and most probably afterwards it's not going. But if you consider the port search, right, that has to handle a lot of event like link detect or link down or any other topology changes. So I thought it's logically better to have it.
Yeah, my point is just want to save the communication between two container, right?
Yeah, actually, the reason why we wanted to couple it to the transceiver daemon is that, at the end of the day, it's like all the media settings, we want to read the EEPROM, and there is a place where, you're going to query the EEPROM. So are there any tight timing requirements for the transceiver daemon? We can think of optimizing it. For example, we can, load the JSON file into a dictionary and do some such optimizations. So would that help? And are there any timing requirements for the transceiver daemon?
Hey, Sudarshan, I have a question in terms of, what will be the flow if there is a, dynamic port breakout mode supported?
The dynamic port breakout mode is supported. I think that will be independent of optics detect, right? So whenever the optics detect happens, the settings will be conveyed based on the optics. So these settings will be based on the media type, right? So I don't think that will be affected. If you have, if there is a, say, a breakout cable inserted, the transceiver daemon will still notify it's a breakout cable, and the breakout cable's corresponding settings will be programmed. So after that, I think if the port breakout is done, I think the settings will be still valid, or if not, the settings can be replayed based on the saved value.
So here's my question. I think before you mentioned this transfer the JSON is taking the physical port, the non-breakout port names, right? And define those parameters for the non-breakout. For example, if I have a 40G QSCP port, I plug in this 4x10 breakout cable into that, and the ASIC actually break out them into 4 ports. So in this case, you know, how do you communicate the port to the port OC agent? You know, if you're communicating the non-breakout port to the OC agent, then does it mean the OC agent need to find out, you know, the breakout port and configure them one by one? Because in the side APIs, it's going to use a logical port, which is a port that has been breakout, and then supply the lane informations, right?
Yeah, I think that's a good question. Yes, I think the so currently for similar settings, I'm not sure how it's done in the orchestration agent, but the if there is a mapping that can be used to find the corresponding in the SOI object IDs based on the port, and those can be programmed accordingly. Say if the Ethernet 0 maps to 0, 1 and 2, 3, and the settings have been conveyed for Ethernet 0. So what effectively will be is like the orchestration agent figures out that it's a breakout port, and the settings will be for 4 lanes. So the settings will be mapped for the 4 ports, and it will be individually programmed.
So okay, so because I think the port OCG eventually is providing AppDB interest for others to write, right? So for example, you know, you probably would define some AppDB interest for the media settings for port. In this case, port OCG currently, I think, is always taking the logical port. It's not the, you know, the front panel physical port. It's always the logical port. If you have a breakout, then it's the breakout port names in their AppDB. So if we want to follow this, it means that the transducer D need to know the breakout and then figure out, you know, for physical port, what are the breakout ports that in the system, and then give the settings, you know, break out your lane information, those media settings into the corresponding to the logical port and send to the port OC agent.
So what you effectively say is it's the job of the transceiver daemon to figure out that this is a breakout port, read the settings from the file, and do the lane mappings for the particular logical ports, and convey the information using logical ports, right?
Yeah.
Yeah, that can be done. Sure. I'll make those changes in the document. Sure. Thanks for the feedback.
I have a question. If this mechanism can be bypassed in case that we don't need or want to provide any default setting or something, you know, specific for each module per port, if we're doing it, you know, in the firmware or somewhere else automatically, and we don't need to specify for each module.
Okay.
So, for instance, if we, I don't know, provide an empty file or a file with just a specific module, let's say.
Yeah, if there is no media settings file, right?
I think you're breaking again.
That will be taken care. If there is no media settings file, there will be no. Hello.
Yeah, Sudarshan, you're back.
Yeah, can you please repeat the question?
Sorry. Do you want me to repeat the question?
So everyone able to hear me?
Yeah, you're audible, Sudarshan. Go ahead, please.
Hello?
Yes.
Can you hear me?
So what was the question?
So the question was if there's a way to bypass this mechanism in case that we don't need to provide or to configure those values through the SI or through the SONiC, and can we provide like an empty file or something, or a way to bypass it, and then we want to, configure those values, and it will use what the ASIC is already tuning or providing or configuring the transceivers, for instance. If we are doing it automatically, or in the firmware, we are configuring the transceiver based on the relevant optics and the correct values, and we don't need to specify any default values and things like that. Is this something that we can do and bypass, or we need to provide default values for each media and each port?
So Padman?
Yeah, I think the answer would be that you're asking whether it is mandatory to go through this process or not. I mean, it's like whether you can program it through your, say, config.bcm itself or through your ASIC vendor specific files. Yeah, I think that should be possible. You're asking whether the media.json file can be empty, in which case this mechanism will not apply. And if you have a platform specific way of doing it, then you would directly use some backend way of programming it.
Okay.
But if you want to do it through the SI, I think this would be the preferred way.
Yeah, of course. I mean, if we don't need to do any programming, then
yeah, it would be desirable to do it this way. So but if for some other reasons you want to do it through a backend way, I think it should be possible. It should still be possible, because this doesn't overrule the other. I mean, your ability to use some other firmware way of configuring, right? It does not override that. So
yeah.
So I have given the link to the pull request in the chat. So everyone is welcome to give their comments. So are there any other questions?
I have one comment. I think there was a previous, I think there was some discussion whether the portal agent should read the media file or the transceiver D to read the media file. Yeah, so I thought, I think currently we're thinking about it, but sometimes the device may have external timers, retimers, or the external files. Those modules, I think currently, it's they may have a separate API to program, which is not going to the side at all. So I think if it makes sense to put those functionalities into the transducer D if there's other APIs to configure those settings, then it doesn't have to go to the portal agent. But still, for example, maybe the port have an external file and the file needs some parameter tunings, then that can be also later to be put into this JSON file. And then in that case, the transmitter D does not need to talk with port OC agent, right? So it can talk to some other entities or using other APIs to configure them directly.
Okay, so yeah, as Padman has said, if anything that needs a SI programming, like the whatever we have specified, so that has to go through the port. So if there are any other platform specific files, yes, that need not go through this. So any other question?
Yeah. Is our understanding correct, Johan?
Yeah.
Okay.
Yeah.
I think Kibo had a question on whether, it's like we asked a question on whether XCBRD has any other timing requirements. We will attempt the optimizations, try to create a dictionary. It's like when XCBRD starts, but are there any other timing considerations? Because it's going to do the extra, after an OER, it's going to do the extra operation of trying to, search through the dictionary and stuff like that. So it will be great if you let us know of any time constraints upfront.
Actually, Padman, yeah, I have done a prototype. So based on that, figured out that having as a dictionary during the boot up saves a lot of time. So that's the way we plan to make the changes.
Okay. Okay.
So any other questions? Yeah, thanks everyone.
Okay, yeah, thank you, for driving the conversation. Just quickly confirm is this under the SONiC pull request, or this is on your own GitHub?
This is under the SONiC pull request. So I have pushed it into my GitHub, and then I have raised a pull request. So I have specified the pull request in the chat window.
Yeah, that's great. Okay, thanks. So if you have any comments, please put it there so that we can get it addressed. Okay, ask once more if there is any thoughts or comment. Okay, if no, thank you. There is no community meeting next week, and we will talk to everyone in a few weeks. Thanks, everyone. Bye.
Platform specific.